Trimble Connect is our collaboration platform, so it will feature heavily during our demos. Before jumping onto the novelties, let's recap on what does Tekla Structures have to offer to the cast in place industry. We have summarized our solution with 3 ideas called model, plan, pour. So create a digital copy of the structure to be built with the best 3D modeling software on the planet, Tekla Structures. Then use the model to get organized, resolve conflicts and constructability issues, RFIs, do quantity takeoffs, budgeting and scheduling, and then go to site. Bring the models and drawings on tablets, for example, or send layout points to total stations. We've got you covered. This schematics puts a bit of meat on the bone. It gives a bit more details on the model plan pour concept. So Tekla covers the whole workflow, from taking the design information through converting it to constructible data and then going onto the construction site. All the improvements and novelties you will see during this presentation will touch a lot of these icons, so let's just dive straight into it. So I have divided my presentation according to 3 main areas of the Tekla Structure software: modeling, documentation or drawings, and finally interoperability. So let's start by having a look at improvements in the modeling space. The first thing you will stumble upon when you open the new Tekla Structures version is probably the instructor side pane. So this is a new way for you to obtain immediate help while using our software. What we have essentially done is introduce a new side pane space that opens every time a command is activated in Tekla, for example from the ribbon. Most of these spaces on the side pane contain short instructive videos that run after executing a command, as well as providing links, for example, to YouTube videos or more comprehensive online help pages. The side pane instructor is available for core commands as well as tools and applications. It's also available in 16 different languages that you can change at your will. Also, users and companies who create their own, for example, their own tools, or just want to edit existing tools, can do so with the plus button on the top right hand corner of the side pane. In this version, we have also invested some time and effort in making some of the older commands work better and easier. Take, for example, copy and move commands. As you can see from the videos, what we have done is we have added a direct manipulation preview to help you determine more correctly the destination of the objects once they are moved, such as in the video on the left, or copied, such as the video on the right. As you can see, this might work when you select single or several objects, or also if you select hierarchical objects. So for example, if you select a cast unit, expect that the concrete, the embeds, the rebar, and any details will move or copied as well with the corresponding preview. We have also added convenient shortcuts to control the rotation and offset of parts. To gives a small preview of how this works, I'm selecting a column, and using the Alt and the arrows in your keyboard, I can offset the column as I want to. Same with the slab. Previously, we would have to control this from the side pane, which was pretty much guesswork. Using the Alt and space, I control the rotation along the handles that created the part. And finally, we have renewed the old split command to now work much better for slabs. It was a very good command for splitting beams and columns and this kind of longitudinal extrusion type of objects, but not really for slabs and plates. Let's see how to use it in action. You can find the command on the quick search. And what we have essentially done is we have borrowed the logic that we use for our pour break commands, and we applied it to the splitting of slabs. Now it should be a lot easier and a lot more user-friendly to create not only linear splits, but also polygonal splits for slabs. And this can be a useful alternative to using pour breaks. For example, when you just want to bring down the complexity of a very big slab with perhaps a lot of details and cuts, and to make it into a much more manageable unit. We have also made in this version performance improvements across the board. Some personal favorite of mine though has to be the performance improvements related to pores and working with pores. So operations such as opening and model views that contain pores, moving and modifying casting place parts, which are the building blocks of pores, calculating pore units. Pore units are basically our assemblies in the casting place world, so calculating them adds all the rebar and embeds that belong to a pore unit, creating and modifying pore breaks, etc. All of these will have been made faster. Let's watch a couple of videos to give you an idea of what you can expect. Here I'm just adding a very simple pore break in this slab. And due to the length of the presentation, I've kept the operations quite simple. But this gives you an idea of the size of the improvements that you might expect. So in this example, it's almost 4 times faster to insert a very simple pore break. Now that the slab split, let's reassign the rebars to the correct pore units, and we do that by calculating the pore units. Again, this is an operation that relies on solid clashing. So the improvements that we have made it more than 3 times faster in this particular example. The end result, and this is just an extra, is always correct, and the rebars have been assigned to the correct split slab pore unit. This is just another extra video. Here I'm copying a pore break inside a structure that contains already a lot of pore breaks. And it's in this kind of situations where we have a lot more complexity, a lot of other pore breaks that depend on other pore breaks, that we can see the biggest improvements. So these numbers do not tell the whole story, and the amount of improvements will depend largely on the types of models and structures that you have, cuts, complexity, curvature, etc. But hopefully this gives you an idea of the level of improvements that we have made, which to me, I'm very happy with them. And another lasting comment is that we have instanced a lot of solids, and this might influence a lot of models that contain, for example, not only casting place, but steel and precast parts, especially if the parts have been repeated. Instancing of solid basically means that we only create solids once for objects that share the same shape or geometry. So you can imagine, for example, things like bricks, where we have thousands of parts that share the same geometry. We don't have to recalculate solids anymore for all of them. And this will manifest itself in improvements, for example, in export, creation of drawings, opening of modeling views, etc. And finally, this is a small item, but also it can have a big effect on people who use, for example, pore units. We have changed the way that automatic assignment of objects to pore units behave, in that now precast cast units are not automatically included inside pore units. Rebars, embeds, and steel assemblies are still assigned automatically, but not precast anymore. So this is to avoid a situation where you might have accidentally or on purpose modeled precast cast units to be slightly touching with the concrete of a pore, and they would get absorbed into the pore unit, even though in most of the cases the users did not want that precast to be absorbed. And when the precast belonged to the pore unit, that brought additional complications when we had to deal with, for example, organizer, location breakdown structures, reports, or just filters. Precast cast units will still be able to be manually assigned to pore units, but as I said, not anymore automatically. Let's now look at our first extension of the day, the feed objects. The feed objects is an extension, which means it is an add-on that we download onto Tekla Structures. And it can be found on the Tekla warehouse, which is Tekla's online repository for custom components, applications, profiles, materials, manufactured products like formwork, reinforcement, and templates. The feed objects extension fills a gap that was missing with our core modeling tools, which did a good job in fitting beams and columns, for example, but was lacking when connecting slabs and walls. In this simple example, we will try to fit this yellow wall onto this blue slab that is tilting in two directions. Notice that the tool not only needs to cut off some material, but also fill a gap. So once applied, it will apply cuts, but also add additional material which can be joined onto the rest of the structure. Moving the slab makes the wall adjust and also changes to geometry. So they always are kept connected. The tool not only has options for automatically fitting faces, but it also gives you the ability to manually select them. The tool is versatile and can be used to fit different objects and of any material. It is especially useful when fitting verticals to, for example, complex objects like sloping slabs, since it will try to adjust to the varying contours of the slab, and again reacting to changes. The next feature, the batch editor, can mark a changing point in your productivity. The tool, kind of for a lack for a better term, finds and copy-pastes details from a source assembly or cast unit onto other ones. It does not matter if the target cast units have the same geometry, same numbering series, or if they are numbered at all. The tool will copy and adapt details such as rebar, components, embeds onto those targets with a couple of clicks. In this demonstration, we will start by importing a concrete model from Tekla Structural Designer. Tekla Structural Designer is Trimble's analysis and design software. This step is naturally optional, but it's a good example of the compatibility between different Trimble software. So once the import finishes, we have a reference model that cannot be changed, but has all the relevant data and details such as size, space, grade, and much more. All the rebar data can be seen there, if they are required, including the structural designer fabrication information. We're going to use this information to model rebar sets, which are Tekla's native rebars. And we will try to copy and make the rebars in Tekla look the same as the design intent rebars. Here I'm changing the spacing, changing the grade, changing the size, and soon I have the rebars looking exactly the same. Now let's launch the batch editor. The way it works is that we select our source cast unit, which automatically populates a list of possible targets cast units based on the numbering series. Then we can use further filtering to select exactly the ones we want to copy the details to. But we have an add button, which allows you to edit the list and add target cast units that you want that do not necessarily get caught automatically. The copy button finishes the magic and copies all the rebar and all the details onto those targeted cast units, just with one click. Let's now talk about the list manager, which is a new extension that you will be able to download from the Tekla warehouse. So if you've been using Tekla for a while, you know that Tekla reports are powerful tools, but they have lacked the concept of revisions and change management. The second that report is created and issued, it is in danger of already being out of date, with very few ways to know exactly what has changed between revisions. Let's use the same model that we used in the previous example. We'll use a list manager to create a rebar schedule. The list manager works by creating lists of objects. I can use a filter or an existing drawing to populate this list. Here I'm creating a new list based on a filter. I give it a title, and then use the handed toggles to further narrow down the object types that I would like to include. In this case, I'm just interested in the rebar. Once you define the list, the objects are shown in the tool. Next, you select what single or multiple reports you would like to associate with that list, and you can preview the report at any time. Here, with that button, there we go, our PDF is shown. But before issuing this report, we will see what happens when we make changes to the model. In this example, I will delete this rebar, and also change the grade of another one. As you can imagine, this affects the list that we just created. When we want to issue, the tool checks if numbering is up to date, so you can be warned if you might be issuing an out of date list. When we renumber and refresh the list, you can see at the bottom of the list what objects have been removed or changed. I give a revision letter and press issue, and this creates a report inside a handily labeled issue folder inside the model folder. So this is my issued report there, ready to be sent. The game changer here that you can see when you inquire one of the rebars is that once you've issued reports, the list manager automatically writes the list data to the parts and rebars, creating a permanently traceable issue reports. We can then use this rich data and export it to Trimble Connect, where we can organize rebar by issue number, for example. We'll talk more in depth about Trimble Connect later, but as you can see, we can see model data coming both from Structural Designer or from Tekla Structures. And we're using rebar in this example, but the list manager is not limited to rebars. As I said, you can make a list of anything. So it can be used to track, for example, changes to, for example, the contents of a pour unit, such as embeds or formwork. Tekla, the list manager, and Trimble Connect really can work together to change the way we collaborate, check and issue to project stakeholders or internally, and discuss and close off RFIs. But the improvements related to rebar detailing do not end there. The rebar sets, Tekla's next generation rebar solution, has had some more improvements to talk about. For example, it is not anymore necessary to create a rebar set using several handles along a curve, as you can see on the left. Instead, we can now select the start and end point in a curved edge, and the rebar set will follow that. We also have improvements in automatically detecting tapered and similar rebars to belong to the same numbering group, as well as a new dedicated tab in the Tekla Structures ribbon for easy access to your rebar modeling tools. And then we have a ton of other fixes and improvements that our customers have been requesting to us over the past few months. Let's now have a look at improvements on the second section of our webinar, drawing production. Before jumping onto what's new, and for perhaps to those who are new to Tekla, let's have a quick look at the way drawings in Tekla operate. So drawings in Tekla are created by taking views across the model and projecting them onto the 2D space. Thus, they are intrinsically connected to the model. Any changes that occur in the model, for example here I will change the property called pour date, is reflected in the drawing and marked with a revision cloud. Similarly, we can make also geometric changes. For example, I will resize this foundation. The dimension associated with that foundation is also changed. So what is new in this version is that dimensions such as the one you saw in the foundation can now be associated to those objects at the moment of creation. This can be very useful, especially when there might be several objects, edges, or lines at the same location, making it quite difficult for Tekla to guess which of those objects needs to be chosen for the association to the dimension. The following video demonstrates a small example. You want to make sure that the new dimension creation associativity is ticked in the settings. We will then create a dimension that starts at a location shared both by the grid and the edge of our pour here on the left hand side. In this case, we will choose the grid as a thing to be associated to. On the other side is exactly the same, but in this case, we will choose the pour as the object to be associated to. To test this, we will go back to the model. As you might have guessed, we will move the grid line, and you will see that the dimension that was associated to this grid line changes accordingly. On this side, you guessed it, we'll resize the pour by making this column a little bit wider. And because at creation we associated the dimension to that pour, it also gets flagged correctly. So what we're basically giving you is more control at the time of dimension creation, which leads to fewer surprises in drawing annotations when making changes to the model, for example. The next improvement is quite handy for those users dealing with a lot of layouts in projects. The new version has the option to make changes to table layouts without needing to save those to a master layout file. This reduces considerably the amount of layout files that you have to deal with. Let's go ahead with the video, and we start with our familiar lift drawing here. We go to editors and open the drawing layout editor. For this example, we're going to start without anything new, and we're just going to add another table to the bottom of this drawing and save that to the master layout template. We can close that and open another drawing that shares the same template, and as you can expect, the new table we added is shown in that drawing. So let's go back to our original drawing. Notice that at the top left, our table is clashing with our plan view. We will now use the new feature, and we do that by selecting the table and choosing to exclude the template from layout. Now, if we move the table, this change won't affect the master layout. In the layout editor, excluded tables are marked with brackets, as you can see on the side pane. And to complete the example, we're going to add an extra table that, as you can see, is also being excluded from the master template. We can just close the editor. And now we do the same thing. We open the second drawing, but this time those excluded changes, the new table and the movement of the existing table, are not recorded, so they are not affecting any of the other drawings. Let's now move on to the final section of my presentation and talk about interoperability and see in what new ways you will be able to share models and information between project stakeholders. Let's start by having a look at our Upload to Trimble Connect feature. This feature was introduced in last year's Tekla Structures version. Traditionally, Tekla Structures has supported and continues to support exporting its 3D models in BIM formats such as IFC and 3D DWG. Those can then be uploaded traditionally to Trimble Connect. Trimble Connect is Trimble's open collaboration platform where stakeholders can store, share, review, coordinate, and comment on data-rich 3D building models in real time. With the arrival of the upload feature, though, we have a more direct way of linking a Tekla model to Trimble Connect. Let's now watch a small video that encapsulates this workflow and also shows what is actually new in the 2021 version, which is basically that the upload model now supports our Tekla spores. So we start with our main modeler, and he will start collaboration, meaning that he will link his Tekla Structures model with a Trimble Connect project that already exists, or he can create a new project as well in the same window. Here he's joining the Tekla House project, and just for good measure, he's going to make some changes in the model. He's adding a pore break, splitting the slab into 2 pores, and using the Trimble Connect ribbon tab, he will press the Upload to Model button, and that sends this model to that Trimble Connect project. Another user opens Trimble Connect in his tablet, and as you can see, the teklahouse.tekla file is in the project. He can open it like any other 3D model in Trimble Connect and view it in pretty much a similar way, for example, as you would an IFC. The latest revision of the model is there, so the slab is split into 2. And in Trimble Connect, if this is the first time you see it, you can inquire objects by selecting them and checking all the properties that have been uploaded with it. In this case, you can see the volume, the material, and some pore data as well. Alternatively, you can also select several objects, and using the object browser, you can then do cool stuff like adding up the volumes, for example, and inquiring those. Or you can build your own templates and columns and reports. Okay, back to our main modeler. What he will do now is he will start using model sharing. Model sharing is a technology that allows Tekla Structures users to model at the same time into the same model. So what you do is you invite a user, he's inviting now user number 2, to join him in modeling inside the same model. Up there we have model user number 2, and he will start adding to the same model some formwork. By the way, this is a bit of a preview to my colleague Yudo's presentation. These are what you're seeing now are the formwork placing tools. Highly recommend that you have a look at them. Once she is finished adding his part of the modeling, what she will do is she will do a write out. And this is part of the model sharing technology. Basically means that you write to the cloud any changes that you have made to the model. So she's writing there that formwork has been added, and now she's sending that package out into the cloud. The cool thing is that the upload model in Trimble Connect will also receive this updated information. First of all, though, let's see how user 1 sees this information. Notice at the top left, he has an announcement that there's one package to be downloaded, and he does what we call a read-in. The packages are being processed, and as you can probably imagine, the formwork that has been modeled on that other computer is imported into the model. So now both are in sync. But as I said, at the moment of write out, the information has also traveled to Trimble Connect. You can see the version history there, and by clicking on the latest version, the user using the tablet can see that the formwork is also there. In a similar fashion with the pores, you can navigate them, rotate the views, and when you select a panel, you can see that it has intelligent information such as, for example, what type of panel it is. So as you can see, combining the upload to Trimble Connect with the model sharing technology allows you to have in the cloud a Tekla model that is permanently up to date. So user 1 and user 2 can continue working together, writing out, modeling, reading in changes, while any stakeholder that has access to the Trimble Connect project will have access also to the latest version of that model that is being modeled in Tekla Structures. Let's continue to talk about overlay models. Overlay models are lightweight alternatives to reference models. Reference models are a term we use in Tekla to refer to models that are not native to Tekla, and they exist in formats such as IFC, DWG, and DGNs that we can bring into Tekla Structures modeling space. So overlay models were introduced last year, but the newest version contains improvements that we will see listed here. But let's just watch a video and see more clearly the power of overlay models and the novelties. We continue with the same example as before, and in this case, one of the stakeholders will upload some IFC files to the Trimble Connect project. Remember, this is the project that the model is being linked to, and we will see how he can bring those as overlay models. So back inside Tekla Structures, our user will open Trimble Connector, which is just an interface to the contents of Trimble Connect. After syncing, the IFC files are listed, and making them visible reveals that we have a steel structure and another wing of the concrete frame. Back on the other user, she will upload a second version of the building's wing. Similar procedure, goes into her Windows browser and then puts the IFC there. Our Tekla Structures user gets notified that one of his overlay models is not up to date. So this is the first improvement. It allows the user to see all the versions of a file. Modified objects are colored yellow, so we can see that these slabs have been modified. There's also a notification of exactly what has changed. And green objects mean that they have been added into the new version of the file, like for example these embeds. Toggling on and off different versions allow you to visually see the differences. In this case, you can see that a recess has been added to the slab. There is also access to tolerance settings for some extra control on the amount of changes detected between versions. Let's now run through the rest of what is new, starting with the ability to inquire overlay model objects to see their properties and metadata. For example, here I'm inquiring some of the columns. The second improvement is support for hierarchical selection. Similar to how Tekla Structures objects behave, we can, for example, select the concrete or the pour in this case. But if we go to the assembly selector, we're selecting now the pour unit, which is the concrete and any embeds and rebars that are attached to that. The second novelty is support for clip planes. So now overlay models feel a lot more like Tekla Structures native objects. For example, the clip plane works as such as you would expect. The final interoperability highlight is a big one, and one you can download from the Tekla warehouse as an extension. It allows Tekla Structures users to import Revit and Navisworks files as reference or overlay models into Tekla Structures. The benefit here really is huge. Previously, our customers would need to go through hoops to obtain readable formats of those files, such as, for example, the industry standard IFC. Not only licenses of these softwares would be required, but often hours could be spent exporting the files to IFC formats just so that we can see them in Tekla Structures. This extension allows Tekla to do all the dirty work for you. Here we have our familiar user, and now we're going to use reference models. We could have used also overlay models to import this MEP Navisworks file. As you can see, it comes as a normal reference file that we can use, for example, to see if those pipes fit through that opening in the slab. Similarly, now I'm going to bring a Revit file. After adjusting my offsets, you'll see that the architectural model can be seen in Tekla Structures like any other reference model. This brings me to the end of my presentation, but be sure to check out our release notes for a more comprehensive list of features and improvements that will come with the 2021 version. But don't forget also the Tekla warehouse, which receives new apps and cool content on a regular basis. We have left the best for last, so I leave you with my friend and colleague Yuru, who will guide you through all the new features related to temporary works.
Thank you, Carlos. That was great and exciting stuff. And welcome on my behalf as well to everyone. My name is Jyri Kokkonen. I work as a technical manager here at Trimble. In this section, we are going to cover the main improvements for the temporary works modeling in Tekla Structures 2021. Before jumping into the actual features of the temporary works modeling, I want to cover one core feature that is heavily used with the temporary works modeling, and that is the shape catalog. The shape catalog has been now renewed entirely, and the renewed shape catalog offers easy management and access to the right shapes whenever you need. So you have basically two user interfaces to the shape catalog, one through the file menu, which is the management unit, where you can create new groups and subgroups to your liking. So creating now here a new scaffolding subgroup to drag and drop the shapes into the right categories. You can also star your favorite shapes whenever you need. Or you can add different tags to help finding those later. And so you have then in the catalog different categories for the tags and start items. What you can also see here in the shape catalog is different attributes that you can here modify as well. Once you save away your settings and start modeling, the shape catalog through the item is slightly different without the option to create those folders, but now the folder structure that you have created is visible inside the shape catalog, and all the tags and start items are there as well. So really nice improvement, helping you to find the correct shapes and organizing the content, so it will help your modeling. With Tekla Structures 2021, we have a new addition to the temporary works modeling offering, and that is a Scaffolding Tools extension. The scaffolding tools are really the latest addition to the temporary works tools, and it's complementing the existing formwork placing tools for walls and slabs that we have had already in place. So what are scaffolding tools all about? It's a set of modeling tools in the same way as formwork placing tools, but for creating shoring and scaffolding systems. We start off with the main frame, but then we can add different details like you do in the formwork placing tools. Also, what you can do with the scaffolding tools, you can configure your own system scaffolding or use some of the generic systems that are provided in Tekla Warehouse, like the frame shoring, ring lock systems, or cup lock systems. So go to Tekla Warehouse, to our online warehouse of different tools, as Carlos explained. Download the extension and the scaffolding systems that you would like to try out and get started. So what you can really use it for, I would divide those to two main use cases, either any type of shoring application, whether it's for slab formwork or any other temporary shoring structures, or then naturally you can also create access scaffolding to provide the access or the working platforms. So what is it that the tools offer? We have intuitive tools, the placing automation that will follow the logic of the configured scaffolding system, enabling you easily create those bays with the direct modification previews. So what you see is really what you get as well. So how does the tools look in practice? So when you initiate the tools, you have the main dialog where you can define the spacing, the props, platforms, and verticals. And when starting to create those, you have the preview showing where the shoring towers in this case will be located under the slab formwork and the girders. Another example for the access scaffolding, I'm using here the wall as a guideline to create the base. And what you can do then after the creation, either modify the bay dimensions individually or grab any of the existing bays and extend that to create a new set of bays to a new direction. And you can control these different sections of the scaffold individually. So defining, for example, a new height for this section of the scaffolding. Or then if we would like to add a staircase for the scaffolding, creating a new section for the stairs, adjusting the bay dimensions to be good for the stair components, and then initiate the detailing tools. As the stair tool is using those ledger beams as the input, you can pick those and the previews will show where the stairs will be located. And we can continue adding, for example, the diagonals or the ledgers to desired locations. So when you hover over the model, the preview will show again where the different diagonals will be placed based on the diagonal layout that you have selected. And that's the basic principle of creating those scaffolding structures. Jumping next to the formwork tool highlights, first I would like to highlight some new, renewed and extended content from multiple formwork manufacturers and suppliers that is available in Tekla Warehouse. And this content is also compatible with the formwork placing tools, helping you to automate the modeling. Another formwork tools related highlight that I really want to showcase here is the brand new video series for the content creation for the formwork placing tools. So use the QR code to visit the website and view the video series. It's great content, how to create the formwork placing tool formwork content, how to create the custom components, and how to configure that content to be used with the automated tools. One of the last things is the visualizer improvements. So what we have here is a improvement that you can now create your own materials. So when you have something exported to visualizer, you can now configure and override the existing materials. So create your own textures, custom colors, and apply those to selected parts or areas in the model. So you can have a bitmap in the settings, or then adjust the opacity or the colors based on the needs, how you would like the material to look like. So when you really want to showcase your project, this is a nice improvement for that as well. So you can really make your project shine and show how they will really look in reality. Just showing some examples for the audience who may not be familiar with the visualizer tools so far. Looking really nice. Of course, that's not all there is. There's a bunch of other great tools, such as the crane tool, which is great for lift simulation and checking erection time calculation. As an extension in Tekla Warehouse, we have a TSAP manager, which is a simple tool to manage all the extensions that you have installed, or many other improvements in the core side for cloning and updating the drawings, and that's really improving the quality for dimensions and the marks. And of course, there is much more. Go visit tekla.com to learn more, or have a look at other webinars that have been presented this week. Thanks on my behalf, and I will now return this back to Rosanna.
Thank you, Carlos and Yuri, for this presentation. Wow, we have really amazing things coming up with the new version. Super exciting times. We will pretty soon open up for the questions as a kind reminder for the audience that you can use the control panel to interact with us. Also, you can send questions later after the webinar using our email address tekla.webinar@trimble.com. But before passing this over to the guys, I can answer one important question, when this new version will be available. And the answer is next week, March 17. Here in this slide, you can see a little bit about where to find the new version and other interesting touch point for support and so on. Also notice if you are working with other kind of material or workflows, this week we already have 2 webinars for structural engineers and steel. Tomorrow we have the precast. All these webinars will be available later in our website in tekla.com/webinars. So let's move forward to the